Here is a hard truth about enterprise IT. We didn't kill the monolith because the code was bad. We killed it because our engineering teams got so big for the box. Every few years, a new architectural pattern takes over. We went from monolith to microservices to serverless and now to event-driven architectures. But if you think this evolution is just about writing cleaner code, you are missing the entire part of system design. Architecture is about decoupling. It's about isolating the blast radius so that when one thing breaks, the whole company doesn't go down with it. Today, I am breaking down the 5 stages of cloud architecture, including the AI shift that is about to make event-driven systems look obsolete. Let's dive in. I'm Gokul, I architect enterprise systems here in Middle East, and today we are skipping the beginner tutorials. If you want to understand the actual why behind modern cloud infrastructure and the real tools we use in the production, this is your masterclass. We are tracing the evolution of how we solve problems at massive scale, starting with the oldest pattern in the book. Everything starts with monolith. Think of it as a big box. When a company builds its first application, they put the user interface, the business logic, and the data access layer all inside one single code base. They deploy it onto one server cluster and it connects to one massive relational database. And honestly, the monolith is beautiful. It's fast to build, incredibly easy to do end-to-end testing, and the deployment is just moving one big artifact. When you are a small team trying to launch a product, the monolith is your best friend. But then the company scales. You go from 5 developers to 500. Now you have a massive problem: tight coupling. The monolith doesn't fail because of technology. It fails because of human bottlenecks. When 500 developers are working inside the same code base, a junior engineer making a small typo in the notification module can accidentally crash the core payment engine. So the blast radius is entire company. Furthermore, you can't scale efficiently. If everyone logs in at 9 AM, you can't just scale up the login module. You have to duplicate the entire massive big box across multiple expensive servers, burning through your cloud budget. To solve this human traffic jam, the industry had to take a sledgehammer into the big box and break it into smaller pieces. We traded simplicity for isolation. So we broke the monolith into tiny pieces. We call these microservices. Instead of one big box, we now have 50 small boxes. The payments team has their own service, the inventory team has their own. They each get their own database and they communicate with each other over network. To manage the chaos, we introduced heavy enterprise tools. We put an API gateway like Kong or APG at the front door to route the traffic. We implemented service meshes like Istio to handle security and mutual TLS, MTLS between the boxes. But this created a brand new set of problems. Microservices solved our team scaling problem, but here is the massive trade-off that most engineers ignore. You didn't just eliminate complexity, you moved it to the network. You traded code coupling for network coupling. In a monolith, if service A needs service B, it takes a fraction of a millisecond because they share the same memory. In microservices, service A has to send an HTTP request over the network to service B. And what if the network drops? What if service B is overwhelmed and takes 5 seconds to reply back? If you don't implement strict timeouts and circuit breakers, one slow microservice can cause a cascading failure that takes down your entire API gateway. You isolated the code, but you created a massive, fragile web of synchronous dependencies. So we realized we were spending 40% of our time managing the Kubernetes clusters, API gateways, and network latency. and only 60% of our time writing the business logic. So the infrastructure tax was too high. The cloud providers offered us a deal. They said, what if you didn't have to manage the operating systems at all? This brings us to the level 3, the serverless computing. Think of it as an invisible box. In a traditional microservice, your container sits there running 24/7 waiting for a request. If it's 3 a.m. and no customers are using your app, you're still paying for that compute. With serverless like AWS Lambda, you just upload a function and the cloud provider handles the rest. Serverless is the ultimate FinOps weapon. When a customer clicks a button, the cloud spins up your code in milliseconds, runs the exact task, and shuts it down. You are billed to the millisecond of execution. If you have zero traffic, you pay $0. This is called compute decoupling. You have completely separated your code from the underlying hardware. But the trade-off is control. You lose the ability to tweak the background OS, and you have to architect around cold starts, that slight delay when the cloud spins up your function for the first time. But for high variance workload, serverless is superpower. It allows a small team to build global scale apps without even hiring a systems administrator. But even with serverless, we still had a fundamental flaw. Whether you use microservices or serverless, if service A makes a REST API call to service B, service A has to still wait for the answer. This waiting is called synchronous communication. And at enterprise scale, waiting is the enemy of performance. We needed a way to break the element of time. This brings us to the 2026 enterprise standard, Event-Driven Architecture or EDA. Think of it as a pulse. Microservices decoupled our code, but event-driven architecture decoupled our time. In an older REST architecture, when a customer buys a shirt, the checkout service directly calls the inventory and shipping services. So if the shipping is down, the whole checkout fails. That is a terrible design. In EDA, the checkout service just fires an event into an enterprise message broker like Apache Kafka or IBM MQ. It shouts, hey, an order was placed, and then its job is done. It doesn't care who is listening. The shipping service subscribes to that pulse. It pulls the event and processes it at its own speed. This is temporal decoupling. If the shipping service crashes, the checkout still succeeds. The message just safely waits in the Kafka topic until the service reboots. It is the ultimate way to build resilient, self-healing systems. And this is how major financial institutions and global retailers operate today. You don't ask for data, you react to the state changes in real time. So, monolith to microservices, microservices to serverless, serverless to EDA. Is event-driven architecture the end of the line? Absolutely not. If you want to know where the top tech firms are heading by 2028, it's a shift from reaction to reasoning. I call it Agent-Driven Architecture or ADA. In event-driven architecture, a system reacts to an event based on hard-coded rules written by a human. If X happens, do Y. If Y happens, do Z. But the future of cloud is agentic systems. Instead of a dumb microservices waiting for a trigger, we are deploying autonomous AI agents using orchestration frameworks like LangChain and Microsoft AutoGen. These agents sit on the Kafka event stream and observe. When a complex failure happens, like a sudden drop in a payment gateway, the agent doesn't just trigger a PagerDuty alert. It reasons about the context, dynamically writes a script to reroute the traffic to a backup API, and executes the code and messages the engineering team with the incident report. We are moving from systems that execute logic to systems that generate logic on the fly. This is the shift that changes everything. So, What does this mean for you? It means that the tools, whether it's Istio or IBM MQ or LangChain, will always change. The boxes will get smaller and smaller and slowly disappear and eventually be run by AI. But the architect's mindset, the ability to look at a system and understand the trade-offs of blast radius, network latency, decoupling, that is an evergreen skill. If this breakdown helped you to see the matrix of cloud architecture, keep watching more. If you have any questions, drop down in the comments and I'll jump in to answer them. I'm Gokul. Let's keep building.